Okay, so let's consider the sequence here as k goes from 1 to infinity, minus 1 to the k plus 1 over the cube root of k. So once again, we want to test for convergence, absolute, conditional, or does it just diverge? Well, if we look at the absolute series, we would just be dropping the sign. And this would be k goes from 1 to infinity. We don't have to do any work on this one. I mean, we could try some of our tests and see how it applies to something like 1 over k to the third, but 1 over k to the third we can recognize as a p-series. Right? That's one of our results, was a p-series. So unless we're specifically told use this method, we can leverage our knowledge of p-series. And we know that the exponent is 1/3, and we know that if your exponent is less than 1 in a p-series, actually I think it's less than or equal to 1 in a p-series, we know it's going to diverge. So the absolute one is not going to work. It is not going to converge absolutely. The absolute value one does not work. So we know that the absolute one diverges. So we turn to our alternating series. We say, okay, what about the alternating series? Well, for the alternating series, we begin by looking at the limit of the underlying sequence. Limit as k goes to infinity of 1 over cube root of k. Well, that's definitely going to 0. So that first part of our our alternating series test works. We know that the limit goes to 0. There are a few quick other questions we want to just quickly ask ourselves. Of course, our terms are positive when we're looking at that 1 over cube root of k. And the other thing is we can see that that is definitely a decreasing sequence. Right? It's not increasing because as k gets bigger, 1 over the cube root of k is going to also get bigger, and as the denominator gets bigger, the result gets smaller. So this is a non-decreasing sequence, and so therefore this thing converges. So the alternating series converges by the alternating series test, and therefore we would say that our series converges conditionally. We have conditional convergence this time. So the series converges conditionally.